Hello and welcome to my channel, Rhino here. Today I'm looking at a video that's using pictures of scantily clad women as clickbait for creationist arguments, and I'm not one to pass up an opportunity to use them as my own clickbait, so I have done so. I will also include some men just to keep things even. So let's go!
Crushing evolution theory is fun and easy.
Really? Because replying to creationist videos can be very difficult at times, and most of the time creationists don't even get into very difficult science. So I can't imagine how crushing a theory that has become the cornerstone of basically all biology could possibly be easy. Have you read any scientific papers dealing with evolutionary biology? It's often a struggle for me to understand what the papers are even saying. The idea that refuting them is easy is just laughable.
Here are top creationist arguments. There are two parts to evolution. Microevolution is variation, and macroevolution is morphing from one kind of creature to another.
Well, that's novel, I'll give you that. I've never heard macroevolution described as morphing before. You say these are the top creationist arguments, so these should be the best of the best. So in order to debunk macroevolution, you need to start with describing a mechanism that would prevent the variations that are described in microevolution from piling up to a point where speciation would occur. I have seen creationist sites assert that such a mechanism exists in some sort of genetic barrier or DNA code barrier, depending on which site you're on, but I have never seen anything to suggest that this is more than just a baseless assertion. Ironically, the idea of a barrier was originally proposed by evolutionists in the 1930s, when there was still a debate about whether micro and macroevolution used the same mechanisms. But through genome sequencing, we have found that the mechanisms behind micro and macroevolution are the same. There are no macro-only mechanisms, and as such, the terms macro and microevolution are now just basically used to describe changes in individuals, that's microevolution, as opposed to changes in population, which would be macroevolution. So at this point, with the way those terms are used, if you accept the fact that the population of tawny owls in Finland now have a higher percentage of brown-colored owls than they used to, then, by definition, you accept macroevolution.
Microevolution is quite real, but it is just variation, such as the different breeds of dogs. Macroevolution, on the other hand, is just a mental fantasy. It cannot happen.
Really? Well, please feel free to demonstrate the mechanism you have discovered that prevents microevolutionary changes from adding up to a macro scale. You'll probably win a Nobel Prize for it. Go on, I wait with bated breath.
Go away, baiting!
No, that's not what bated breath... Never mind.
When talking to the public, evolutionists talk microevolution. That's how they sucker everybody into believing the rest of it. All their experiments deal with variation and adaptation, though they try to pass a few off as macroevolution.
Variation leads to adaptation based on selection pressures, and adaptation over long periods of time leads to speciation. What's the problem?
But every creature has limits to how much it can change.
What are these limits? What mechanism imposes these limits? You can assert that these limits exist all you want, but until you demonstrate that these limits are actually real and show a mechanism for them, it will remain an assertion, nothing more.
To morph beyond the limits, mutations in DNA would be needed to provide novel genes and epigenetic RNA.
Well, that sentence didn't make a whole lot of sense. Yes, DNA mutations would be needed, and guess what? They happen. All the time. Pretty much every time DNA is copied, there are at least a few copy error mutations, and these can range from single letter errors to entire genome duplications and several different types of mutations in between these two extremes. And all of these changes can, given enough time, add up to entirely new genes. There are also instances of viral infections providing DNA that our cells end up using for their own purposes. In fact, endogenous retroviruses are one of the ways we can track evolution genetically because of the way viruses work. They insert their DNA into the host cell's genome completely at random, so if you see the exact same endogenous retrovirus in the exact same spot on the genome of two separate species of animals, you can then know that the infection with that particular virus happened to one of their common ancestors. So that covers novel genes. Now, what about epigenetic RNA? Well, as far as I can tell, that isn't actually a thing. Epigenetics is the study of heritable changes in gene expression that do not involve changes to the underlying DNA sequence. Certain types of RNA do play a part in gene silencing, which, as you might expect, is when the expression of certain genes is prevented. So changes to these types of RNA can result in changes to the phenotype without a change in genotype. And to go back to high school biology for a moment, a phenotype is basically the physical manifestation that results from the genotype, which are the genes specific to an individual. So it seems that you just pulled the term epigenetic RNA out of your butt to make yourself sound smart. And also, I know I'll get massacred in the comment section if I let this go without commenting on your ridiculous croc-a-cow or cowodile or whatever you want to call it. That is a straw man. Nobody with a basic understanding of the theory of evolution would ever expect some hybrid animal like that to ever exist. A cow would have a cow baby that is slightly different, and if those differences are favorable, then they have a higher chance of being passed on. But the next generation is also different from the parents, and any favorable differences that they have a higher chance of being passed on and so forth, until these changes pile up to a point where you have a distinct and separate species of cow. And as more time passes, the changes continue to pile up until you have something that's completely different from the original cow. These changes are gradual and slow. Now I have no idea where cow evolution might go in the future, so let's take a look at the past. A great example of this is whale evolution. We essentially have all the transitional forms between modern whales and their land-dwelling ancestors, and no step in the chain is all that much different from the previous step. But I think even the creationists would agree that the sperm whale is a completely different kind from a pachycetus.
Living things are intricate biological machines of mind-boggling sophistication. Mutations in their codes cause problems.
Yeah, they usually do. But then in the rare cases where the change results in an advantage, that advantage then outcompetes the disadvantaged ones. It doesn't need to be a huge advantage, any tiny little improvement will do. And I would like to point out that you use a picture of a person with Down syndrome, which is caused by a partial or full duplication of chromosome 21, of which most people have 2 copies and people with Down syndrome have 3. So it's a mutation that has added an entire chromosome into the genetic code. Now let's go through a hypothetical scenario. There's an outbreak of a new disease. Let's say it's some antibiotic-resistant bacteria, since that's actually a real possibility. But something in the duplicated copy of chromosome 21 allows people with Down syndrome to fight off this bug. There is now a huge selection pressure in favor of Down syndrome, and assuming this bug is fatal and we don't find an artificial means of stopping it, the entire human population eventually has 3 copies of chromosome 21, and now this 3rd copy is free to mutate in other ways that may turn out to be beneficial. So there are 2 things to learn from this hypothetical. First, what is considered to be a problem in one environment could be an advantage in another environment, so there is no universal this mutation is good or this mutation is bad. And second, chromosomal duplication is quite real, which is an addition of genetic material into the genome and can lead to further mutations which give rise to new genes with new functions.
If you are typing and hit the wrong key, the message is confused.
Yes. And in some cases, the meaning of the message is changed in a comprehensible way. Sometimes these small changes can alter the meaning just a little bit, other times they can completely change the meaning.
You know that a mutation in your computer would damage it. Lots of mutations would destroy it.
Exactly. A computer is a designed object that was made in a specific way for a specific purpose. Mess with the code or hardware randomly, and it will probably stop working because these changes go against its underlying design. Living organisms, on the other hand, were not designed for any particular purpose, and as such have a lot of apparently useless genetic material hanging around. So random changes to most of this genetic material will result in nothing. Just neutral mutations, adding up over time. And these accumulated neutral mutations are another way that we can genetically track evolution. Neutral mutations don't experience selection pressure in one way or another, so once they appear they are quite stable because of the lack of selection pressure. It would be incredibly rare for there to be more than a handful of the same mutation in the same place on the genome in different individuals, so they can use these mutations when investigating the evolution of certain populations.
An evolutionist believes it just might improve it.
Well, like I said, in a designed system, there would be very little, if any, code or hardware that could be randomly changed and result in improvements. But in a system that was put together through the process of evolution and natural selection, there is plenty of room for mutations that won't harm the system, and so beneficial mutations become much more likely.
For evolutionists, mutation is not only important, it's all they've got.
Yeah, without mutation, evolution wouldn't work. I'll grant you that. However, since we know mutation is quite common, and that beneficial mutations happen all the time, that's not a problem.
Evolutionists like to call it the law, not theory of evolution.
Nope.
Nobody calls it the law of evolution. Though creationists do seem to have this misunderstanding that a theory is the same as an hypothesis, but when it's proven it graduates to the status of law. But that's just not how it works. A theory is a body that explains various laws and hypotheses, so a theory can contain laws. A law is simply a statement that describes something factual that's based on repeated experimental observations. Often, though not always, a law will come in the form of a fairly simple mathematical equation. Laws, however, do not even attempt to explain a mechanism. All a law does is say that in a given situation, if you plug the appropriate numbers into the appropriate spots in the equation, this will be the result. There is no explanatory power there. That's where the theories come in. That's why we still have things like cell theory and the theory of gravity when we know for a fact that organisms are made of cells and that gravity exists. They are still theories because a law wouldn't be able to explain anything about them other than the fact that they work.
The very foundation of biology that made every type of plant and animal that ever was, one morphing from another, all based on mutations beyond the limit of variation. It would take many constructive mutations to make just one new part and integrate it into an animal over a very long time.
Well, since life has been around for a few billion years, that's not really a problem. But it's also not entirely true. I mean, take snakes, for instance. Different kinds of snakes have different numbers of vertebrae, and with each vertebrae comes a set of blood vessels, nerves, muscles, and other tissues. But obviously the number of vertebrae has changed between snakes at some point, as different snakes have different numbers of vertebrae. You don't even have to accept evolution between kinds for this, as they are all snake kind. But it doesn't take a large mutation to change the number of vertebrae, just a simple mutation during embryonic development that instructs the embryo to repeat the process of building a vertebrae one more time. Now you have a whole new structure with its accompanying sets of blood vessels and all that wasn't in the previous generation. So within one generation you can have a rather large deviation, and if that is selected for, it will make its way into the general population.
Unfortunately for the theory of evolution, while there are cases of parts disappearing from animals, no new parts have ever been detected under construction in any of the millions of plants and animals in the world. Yet if evolution is ongoing, there should be thousands.
Well, ignoring the things that we do know about, like the snake vertebrae, we actually can't see where evolution is going to take us in the future, so we don't know which new structures might develop. And since we don't know what these new structures will look like, we don't know what their primitive forms would be. So what looks like a fully developed diaphragm in a modern human might, a few 100,000 years from now, be a completely new organ with a completely new function, but to us it looks like it's a muscle to help us breathe. Evolution is good at adapting existing organs to new functions over time, so there could well be thousands of partly developed organs and structures in the human body alone, but we wouldn't know it because we don't see the finished product.
For macroevolution to happen, there would have to be a natural force that invents and builds, but there isn't one.
Reproduction plus mutation plus natural selection equals a combination of natural forces that can invent and build.
There is the opposite, a tendency to disintegrate. It is called, yes, the Second Law of Thermodynamics.
The reason he said that like he's tired of bringing it up is because this is one of the most debunked claims of creationism. The Second Law of Thermodynamics applies to closed systems where no energy is introduced or can escape from the system. If you look up in the sky in the daytime, you will probably see a really bright ball-looking thing. That's called the sun. It constantly injects energy into the Earth, meaning that the Earth is not a closed system. Because of this infusion of energy, we get to enjoy a temporary reversal of entropy that a few billion years from now will succumb to the overall entropy that will eventually take over the whole universe.
For the Law of Entropy, which is a measure of disorder. It reads, "A natural process always takes place in such a direction as to cause an increase in the entropy or disorder of the system plus the environment. In the case of an isolated system, it is the entropy of the system that tends to increase."
Beautiful. You read the answer right there. In the case of an isolated system. What makes you think the Earth is an isolated system to which this would apply?
When they hear that, evolutionists immediately say, that only applies to closed systems and biological creatures are open systems.
Well, I mean, that's not wrong. Biological creatures are open systems, taking in energy from their surroundings, but I'm looking at the Earth as a whole here.
As if they know what they're talking about. Since most people know nothing about this, the discussion is over.
Okay, well, please, do go on and explain why you consider biological organisms, which have to take in energy from their surroundings, closed systems. Or why the Earth, which gets furiously pounded with energy from the sun all day, every day, is a closed system.
Here is the reality. The second law is defined in terms of an isolated system for the sake of simplicity, but there are no isolated systems in nature.
You're so close. So close.
It applies to every situation, all systems.
And you're gone again. No, you see, like I said before, a scientific law is just basically a statement of fact. In situation X, Y will happen every time. So in the case of thermodynamics, situation X is a closed system with usable energy. Y is the fact that over time, in this closed system, the energy will become less and less useful. You are mostly correct in saying that there are no closed systems in nature, with the possible exception of the universe as a whole. But that doesn't suddenly make the second law of thermodynamics applicable to every single situation now. That just means that nature isn't as simple as the laws of thermodynamics. So just because situation X doesn't happen in nature, that does not mean that Y will always happen regardless of the situation. In fact, that can mean the opposite of Y is possible in nature, since nature rarely, if ever, causes situation X. So what use is thermodynamics if it only applies to situations that rarely occur in nature? Because it helps us understand how energy transfer works, and without an understanding of thermodynamics, several things we take for granted today probably would never have been invented, like the internal combustion engine, refrigerators, air conditioners, things like that. There are also several close enough scenarios where the laws can be loosely applied with the understanding that it's not a closed system and that the external factors will affect the result, such as, like, basic example, an ice cube melting in a glass of water. You can use thermodynamics to calculate the temperature of the water once the ice is melted into it, but with the understanding that the environmental temperature will change the result. My point is that nature will never exactly reflect what any one law says about it, because there will always be external factors. That doesn't mean that the law is universally applicable, or that it should be thrown out. It just means you have to do your best to account for the external factors when using it.
In 1859, the great scientist Louis Pasteur settled the question of whether life can arise spontaneously from chemicals. His experiments showed that life only comes from life by reproduction.
Well, that was a gross mischaracterization of what Louis Pasteur did. He didn't show that life couldn't arise spontaneously from chemicals. He showed that things like mold and maggots didn't spontaneously pop into existence as the result of dissipating life force from a dead organism. As in, they didn't know where maggots and mold came from back then, so the hypothesis was essentially that they popped out of nowhere. It had nothing to do with the chemicals that would have been needed for abiogenesis. It was all about already developed complex life showing up out of nowhere. Unless, of course, you think that keeping a sterilized sample of broth isolated from the environment and showing that it didn't spoil somehow proves that self-replicating molecules couldn't develop on the early Earth, which would have had characteristics that are very different from any soup broth that I have tasted.
It was the same year Darwin's book On the Origin of Species was published, and of course evolution requires that life on Earth began by assembling spontaneously from chemicals.
Nope. Evolution just requires that life began at some point, and that this first life was much simpler than the vast diversity of life we see today. How the life originally got there doesn't matter. Abiogenesis is the leading hypothesis of how life started, but should it turn out to be incorrect, evolution is still true.
These days, scientists speculate that RNA, not DNA, was key to the origin of life.
These days, scientists speculate. As long as these days go back to 1962 when it was first proposed by Alexander Rich.
But RNA is difficult even for biochemists to make outside of a living cell.
So, do you know what else is difficult? Growing an embryo from a zygote to baby. Scientists can't do it with our current technology. The longest an embryo has been able to survive outside of a womb is 13 days. Does this mean that it's impossible for an embryo to develop into a baby in nature?
It falls apart easily, and its abilities are limited.
Much like a freshly fertilized human embryo.
RNA is not such a good candidate for the origin of life.
RNA is also not the only candidate. And it's not as bad a candidate as you're making it out to be. The main problem with abiogenesis is that life in its current form uses all three of these macromolecules, RNA, DNA, and proteins, for metabolism. The idea of them all arising together spontaneously in a way that would result in life is highly unlikely, so the question then becomes, which one came first, and how did it metabolize in a way that could eventually lead to the metabolism that we see in nature today? And once again, I would like to point out that abiogenesis is not necessary for evolution, so at this point you're on a rabbit trail. Even if you somehow managed to single-handedly debunk the RNA world hypothesis, it wouldn't touch evolution at all.
In 1953, Miller and Urey became famous with an experiment that made a few types of the building blocks of proteins, amino acids. No doubt your science teachers made a big deal of this, leaving you with the impression that it was the first step in the glorious discovery of how life arose from chemicals. They probably didn't mention that the search has been a failure. As veteran origin of life research biochemist Robert Shapiro put it, the origin of life field has been short on progress over the past half-century.
So what? Miller and Urey demonstrated that the building blocks of life can form naturally, and the simulated environment has been changed to be more accurate to our understanding of the early Earth's environment. We have continued to show that the building blocks of life can form naturally in a variety of environments. If we make no progress for the rest of human existence, that's still pretty damn significant. But that quote is from 2011. In 2017, scientists were able to create cells with synthetic DNA in them, including the addition of 2 new bases in addition to the 4 naturally occurring ones. Not specifically abiogenesis research, but it ties in pretty well, and it's a pretty major breakthrough, and it demonstrates our increased understanding of how life works, which will almost certainly lead to further breakthroughs in abiogenesis research. The rest of his video is just a recap, so these 2 arguments are what he thinks are the
top creationist arguments,
and neither was particularly good. That's all for today. Next week I will be camping in a location with no internet access and incredibly spotty cell reception, so I will be having a guest video on the 8th, then back to normal on the 15th, so feel free to follow me on Twitter and Facebook and support me on Patreon. See you next time!